Today we're going to start Unit 3, and you may be wondering, why do I have music playing in the background, and why do I have food in our video? Well, the first thing I want you to do is I want you to think about these peanut M&Ms, these blow pop, and these Oreo cookies. And I'm curious to know if you have any idea of what they may have in common. So one of the things that they do have in common, and it may be the only thing that they have in common, is that in each of these, let me open one. There's the Oreo cookie. We'll try to turn it on its side. Here is the M&M. And, well, this is going to be a little tough. And I'm not going to, this one will be too difficult. This one will be too difficult. But what do they all have in common? Well, notice that this M&M has a peanut inside. This cookie has cream on the inside. And then on the inside of this blow pop, there's bubble gum on the inside. So each of these have something inside. And sometimes to get to the inside, you have to eat what's on the outside. So most people will take this M&M and just pop it in their mouth, eat it, and go on about their business. And many will just throw this little mini Oreo cookie in their mouth, eat it, and go on. Now that's a little hard on the lollipop. However, some people may actually eat the outside and then eat what's on the inside last, or at least eat what's on the outside first. Well, you have, not necessarily, but it's best to do that with the lollipop. You eat the lollipop, the hard lollipop on the outside, and then you get to the inside bubble gum. Years ago, there used to be a commercial that would say, how many licks does it take to get to, well, in that case, it was a Tootsie Roll. But anyway, so what do these all have in common? Well, these are going to all kind of lead us into what we're going to talk about today. Notice that, and I'm going to clean these up. I am going to pop these in my mouth, except for the lollipop. And I'm going to clean off my paper. And what our first lesson in Unit 3 is about is composite functions, and how do we find the derivative of composite functions. And a composite function, if you recall from Algebra 2 and Pre-Cal, a composite function is where one function is inside another function. So let's say we have a function named h of x, and let's say that that's defined as f of g of x, where g of x is inside the f function. So let's say we have a function f of x. Let's say f of x is the square root of x. And let's say that g of x is x squared plus 1. Then h of x, based on how we've defined h of x, would be f of g of x, which would then equal the g function inside f, so that would be the square root of x squared plus 1. So the question is how do we find the derivative of a composite function? So derivatives of composite functions. If you have a function where one function is inside another, then the derivative will be f prime of the inside times the derivative of the inside. Okay, so let's just start looking at an example. So here we have a function f of x, and it's defined as the function 3x squared plus 1, which is raised to the second power. So here we have an outside function and we have an inside function, okay? So the outside function would be the cookie part and the inside would be the cream, or the outside would be the hard lollipop and the inside would be the bubble gum. So which is each? Well, the inside is easy enough, 3x squared plus 1. The outside would be considered x squared. What is 3x squared plus 1 being put into? Well, 3x squared plus 1 is being put into a variable that is being squared. So that's your outside. So now how do you find the derivative using the chain rule? Well, you do so by f prime of x equals, you find the derivative of the outside, so find the derivative of the cookie, so that's 2 times the stuff inside to the first power. I'm using the power rule, and I'm going to multiply that by the derivative of the inside. So the derivative of 3x squared plus 1 is 6x. So why did I leave this alone? Well, you leave this alone because in the chain rule, with the chain rule, you are finding the derivative of the outside and keeping the inside. So this would be 3x squared plus 1. So that would be 2 times the stuff raised to the first power times the derivative of the stuff. So you are that is how the chain rule works. You take the derivative of the outside and then you take the derivative of the inside. But now when the outside, you keep the inside when you're doing the derivative of the outside. Okay, what does that clean up to be? 12x times 3x squared plus 1. Now, the other approach that we could have, and we could distribute here, and I'm not necessarily going to make you do this. It's not necessarily important to do this. But if this were a multiple choice question, you would need to be able to recognize that this version is the same as this version. So, is there another way we could handle this? You bet. We could multiply these two together. We could actually FOIL this or square this, then take the derivative, and we would end up with the same thing. So sometimes you have choices. Sometimes you definitely have choices. And but what if we have something like this? I would say that the chain rule is going to be very useful here because that power is 100. I do not want to have to write this out 100 times and then multiply, and that would be an endless headache. So what is the inside? Well, the inside is x cubed minus 1. So to find the derivative, y prime, we have something raised to the 100 power. So I'm going to begin using the power rule. So that would be 100 times the stuff raised to the 99th power, and that stuff is x cubed minus 1. Now I have to multiply it by the derivative of the stuff. So that's 3x squared. So when we find the derivative, if this would clean up to be 300x squared times x cubed minus 1 to the 99th. And no, you would never have to multiply that out. But look how quick that, using the chain rule, we chained it out and we found the derivative much, much quicker. we wouldn't even be remotely close to being finished multiplying this expression out 100 times. So that's the beauty. So let's go back to the original expression where we had that, well, we called it h of x up here, but f of x is the square root of x squared plus 1. All right, well, we don't know, well, we do know how to find the derivative of a radical. The first thing we want to do is write the radical in terms of a power. And so this would be x squared plus 1 raised to the 1/2 power. That's the first thing you need to do. Now we have this expression, this inside stuff, x squared plus 1, raised to a power. So the inside is x squared plus 1. The outside, you're going to use the power rule. So f prime of x equals 1/2 the stuff to the negative 1/2 power times the derivative of the stuff. So that would be 2x. And my stuff stays the same. When you find the derivative of the outside, it's like you're eating the cookie, keeping the cream, and then multiplying it by the derivative of the cream. Okay? So you might hear me talk sometimes when talking about the chain rule, it's derivative of outside times the derivative of inside. Okay, and let's go to another couple of examples. Here, you might be inclined, or your first thought might be to use the quotient rule, and you can, but it would be really, I think, a longer approach. Don't forget that we can actually take something that's in the denominator, bring it to the numerator, and make the power negative. So here's the first thing I'm going to do. I'm going to rewrite. I'm going to come over here. I'm going to rewrite f of x as x squared plus x plus 1. And I'm going to raise that to the 1/3 power. And when I bring it to the numerator, it becomes negative 1/3. Now I can find the derivative by using the chain rule. F prime of x equals, so I'm going to take the derivative of the outside using the power rule, so negative 1/3 times the stuff, x squared plus x plus 1. And be careful when you subtract 1 from negative 1/3. You get negative 4/3, and then you will multiply that by the derivative of the stuff, which is, please put this in parentheses, 2x plus 1. And we're going to leave it just like that. No need to clean that up at all. All right, now for the next one. Next one is going to get a little lengthier, but it's not a big deal. We can handle this. First, I see this t minus 2 over 2t plus 1, and it's inside parentheses. So that to me looks like the inside stuff. And so my outside is going to be something raised to the 9th power. Okay, so, all right, so I'm going to begin, when finding g prime of x, I'm going to begin by taking 9 and multiplying it by the stuff raised to the 8th power. And I'm going to go ahead and put the stuff in there, which is t minus 2 over 2t plus 1. And just for the sake of understanding, this should really be g of t. This should be g of t. I just saw that. And this should be g prime of t. Okay, so mess my variables up there. Okay, so now we're up to multiplying by the derivative of the inside. Okay, now the inside, you're going to have to use the quotient rule, and that would be low 2t plus 1 times the derivative of high, which would be 1, minus high t minus 2 times the derivative of low, which is 2, and all of that is over low, 2t plus 1 cubed. Okay, now I'm leaving it at that. Okay, I'm going to just leave it as this. I will tell you though, we could clean this up and maybe clean it up a little bit, but I'm just going to leave it as such. I don't think you would ever really need to do that. All right, so that's going to wrap up this portion of the video, and this will get a good start on the chain rule. And our next video, we will look at the remainder of the examples for lesson 1. So enjoy your chain rule treats.